Hi, everybody. Welcome to day 8. We're going to go through our slides for today on parallel and series circuits. So your job today is to watch this presentation or go through the slides on your own and complete the exit ticket by 2:30 today. So the 2:30 exit ticket comes directly from today's slides. Today what we're going to be looking at is identifying the parts of a circuit diagram and then identifying the properties of parallel and series circuits and the differences between them. So the first thing that we kind of got to touch on today is circuit diagrams or schematics. So they're drawings used to create symbols and on-paper definitions of what a circuit consists of. So they're meant to be neat and easy to read, and they're very, very easy to plan and design. So there's lots of symbols there that we use in these schematics. Now, one of the things is that an open circuit will have a break somewhere in that circuit, and an open circuit is a circuit where charge cannot flow. Think of a light switch being off, right? So if you turn a light switch off, you're actually opening up the circuit, you're breaking the connection and stopping the electrons from flowing. A closed circuit then is something that's turned on. The circuit is complete and it can go around and around in a circle. So if you think about a closed circuit, you can think about it as if the switch is on. There's two types. We have series, which is a simple, easy, straightforward way of creating a circuit, and then parallel, which is a little more complicated, but really, really useful in the real world. So the big thing with a series circuit is that electrons only have one pathway in which they can flow. So current only can go one direction, right? It can only go through the circuit. So when it goes through, it has to go through all 3 light bulbs and through the switch and back to the battery. And that's going to be its circuit. Similarly here, we got the battery through the light bulb and back. From the battery through the light bulbs and back. There's only one pathway. There's no other place it can go. And that means if there's something that's stopping it somewhere in this light bulb, let's say this light bulb burns out, we're going to stop what happens, the electron flow to the other ones. So what happens to one happens to all in a series circuit. If you have a bunch of lights in series, like old Christmas lights, if one goes out, they all go out. So again, if one of them stops working, they all stop working. No flow can go through because that actually opens up the circuit. So anytime a light bulb breaks or a resistor stops the flow of electrons in a series circuit, all right, we actually have an open circuit.
I didn't get that. Could you try again?
Come on. All right. So in a series circuit, as we add resistors or as we add light bulbs, a couple things actually happen. So as you add up resistance or you add more light bulbs, the current is actually going to drop. So you can think of this as a straightforward V equals IR. The voltage from the battery or from the power source stays the same. And as you add more resistance or more light bulbs, you're going to actually decrease the current to keep that voltage the same. So the light bulbs are going to get dimmer and dimmer and dimmer and dimmer the more light bulbs you add. Now, the other type is called a parallel circuit. In a parallel circuit, there are 2 or more pathways in which electrons can flow or that current can go. So it doesn't have to just follow one path. There's always a second path at least, if not a third, fourth, fifth. These are really useful because what happens to one doesn't happen to all of them in this case. And you'll see that our light bulbs especially don't lose a lot of brightness when we use these. So most of your appliances and things in your home are wired on a parallel circuit. So if we look at our example here on the left, if there, come on, start moving. We have electrons that can flow through this light bulb and back, or they can go through this second wire down to that light bulb and back. So there's pathway 1, the top loop, and then there's also pathway 2, which is the bottom loop. So we have pathway 1 and pathway 2 here on this first example to the left. If you look at the one on the right, there are actually three examples, or three pathways. So you can have the very first pathway, all right, through that first light bulb. You can have the second one through the second light bulb, and obviously the third through the third light bulb. Those all produce different channels or different circuits for the electrons to flow. All right, so what happens if one stops working? So in the case of a series, we were stopping all the electrons from flowing. But in a parallel circuit, if one stops the flow, the other one will continue to work because there's still a separate flow of electrons going to that one. So in a series circuit, if one light bulb burns out or breaks, it doesn't stop the whole thing. The current can always flow along one of the other paths. And this is actually really nice for us. So if you add more light bulbs or more resistors to a parallel circuit, not like a series circuit where they're going to get dimmer and dimmer and dimmer the more you add. They'll actually get a little bit different reaction, and they're going to actually increase the current to all the light bulbs until they're all going to be equally uh, light or bright. So if you think about checkout lanes in a grocery store, if you're at the grocery store and there's only one lane open, everybody's got to go through that one. But if we open up more people can go through, so your actual current can go increase, so you can get through the line much, much quicker if there are more ways for those electrons to flow. The kind of problem here is that there are things called short circuits. You've probably heard of them. Short circuits are when electricity is going to take a path of least resistance, meaning that there's going to be no resistor. There's going to be no resistance to the flow of electrons going through that wire. And this is actually really dangerous because this is going to convert a lot of that electrical energy into heat energy, and this is how fires happen. So older buildings or poor wiring, when a short circuit happens, that's when electrical fires start. So this is really actually a pretty big problem. But there's a pretty good way we've taken care of a lot of this, and that's through fuses and circuit breakers, excuse me. So if too much current flows through a fuse, what happens is that the fuse will actually break and stop. It's like opening a switch. And circuit breakers are actual switches that turn off when that flow or that electron or the current gets too high. So if you ever hear someone saying blowing a fuse, there was too much electrical energy or too much current flowing through that circuit, and they blow it to keep them from starting a fire or to keep us safe. And that's why the fuses will trip. Come on. All right, so your job today is to complete the exit ticket by 2:30, and it's based on the stuff we just went over. So good luck. Have a great day.